correct IUPAC name for the following compound is. So if we are looking for an IUPAC name, another way of saying this is the systematic name. So this is a global system of naming that allows chemists around the globe to communicate when they are working with the same compounds. So the first thing we want to do for an alkane like this is we want to locate the longest continuous carbon chain. And in this case, it looks fairly obvious that it's going along the backbone here, just straight across the page, or even up to here or here. If you felt like curving it, it's still just one carbon atom. And then the next thing we want to do is we want to number that chain so that our substituents are on the lowest possible number. So if I number from left to right, 1, 2, 3, 4 is where I hit the first substituent. If I number in the opposite direction, 1, 2 is where we hit the first substituent. So we're going to want to go this way. 1, 2. And again, if I had decided to start 1 here or here, it is exactly the same thing. 3, 4, 5, 6, 7, 8. So our parent chain has 8 carbon atoms. So that means our parent name is octane. And then if we look at the substituents on carbon 2, we have 2 of these 1 carbon atom substituents. So those are methyl groups. So they each get their own number. So 2, 2 indicates they are both attached to carbon number 2. And whenever you have 2 of the same group or more, you use a prefix. So if you have 2, then this is di. So this is dimethyl. So we have 2 methyl groups on carbon number 2. So that's how we communicate that. And on carbon number 5, we have a bromine. Bromine as a substituent is bromo. So we have 5 bromo. And then when we assemble our name, we're going to put this in alphabetical order of our substituents. And they go out in front of the parent chain. So we are comparing the B in bromo to the M in methyl. We do not include that prefix. So B comes first. So our molecule's name is 5-bromo, 2, 2 dimethyl octane. So that is our option C.